The curve y equals x squared plus 3x plus 4 is translated by 2, 0. Find and simplify the equation of the translated curve. Translation by 2, 0 represents a horizontal shift by plus 2 in the x direction. So what we need to do is write another curve that is moved to the right by 2 units. Fortunately, the curve that we are dealing with is a quadratic, and we know a lot about quadratics. One thing that we can do with quadratics is complete the square to find the coordinates of the vertex or the minimum point. If the translated curve is moved to the right by 2 units, then all we need to do is move the x-coordinate of the minimum point by 2 spaces to the right. To do that, we just add 2 to the x-coordinate of the minimum point to get our new minimum point, which is 1/2 and 7/4. And we can write the equation of the quadratic that has a minimum point at 1/2, 7/4 as x minus 1/2 squared plus 7/4. Then to simplify the equation, all we need to do is expand the brackets and combine like terms. Another method to do this is to replace the x with x minus 2, which represents a horizontal shift by plus 2. And then we can simplify the curve by expanding the brackets and combining like terms. And notice that we get the exact same answer after we simplify it. The graph of y equals fx is transformed to the graph of y equals 3f minus x. Describe fully the 2 single transformations which have been combined to give the resulting transformation. When we replace x with a minus x in the function, it is a reflection in the y-axis. Multiplying the whole function by 3 is stretching the function by a scale of 3 in the y-axis direction. These are some common translations that you should know, but in case you're not sure, you can always try it out with a more simple graph like y equals x squared. If we replace the x with minus x in the graph of y equals x squared, we get the same thing. So the graph is in the exact same position, which represents a reflection in the y-axis. Most people would guess that replacing the x with a minus x is either a reflection in the y-axis or a reflection in the x-axis. If it was a reflection in the x-axis, it would be flipped downwards. So therefore, this is a reflection in the y-axis. If we sketch the graph for y equals 3x squared, which is 3 of fx, we can see that it has been stretched upwards. And if you compare the coordinates where x equals 1, it's 1, 1, and 1, 3. Therefore, the y coordinate has been stretched by a scale factor of 3.